Hello guys, welcome to the MACM 101, Discrete Mathematics Tutorial 11. Last 2 weeks, we talked about the permutation and combination. We also learned the binomial coefficients. This week, I will extend the topic to help you learn the concept from finite probability and basic property of integer. Let's go to the first question. In the first question, the question says, the Joshua draws 2 ping pong balls from a ball of 20 ping pong balls, numbered 1 to 20. Provide a sample space for this experiment. If A, the first ball drawn, is replaced before the second ball is drawn, and B, the first ball drawn is not replaced before the second ball is drawn. So it asks you the sample space. So what is the sample space? The set of all outcomes of an experiment is called the sample space. So for the question A, we have 20 tries for the first ball and 20 tries for the second ball, since the ball is replaced before the second draw. Thus, we have a sample space like S equals to 1 to 20 times 1 to 20, right? Or we can represent it as S equals to AI, AJ, where I is greater than equal to 1 and less than equal to 20. And we have J greater than equal to 1 and less than equal to 20. That's the sample space for the question A. For the question B, similarly to the question A, but this time the ball is not replaced after the first ball is drawn. So we have 20 tries for the first ball and 19 tries for the second ball. We have to make sure the second ball, the ball that we draw for the second ball is not equal to the first one. So we have like set the sample space as is AIAJ, where I is greater than equal to 1 and less than equal to 20. And for J, we have J is greater than equal to 1 and less than equal to 20. And I is not equal to J, because we have to make sure that the second ball that we draw is not equal to the first one, right? That's the first question. Here is the question 2. So question 2 says 25 slips of paper numbered from 1 to 25 are placed in a box. If Amy draws 6 of these slips without replacement, what is the probability that A, the second smallest number drawn is 5, B, the fourth largest number drawn is 15, C, the second smallest number drawn is 5 and the fourth largest number drawn is 15. So okay, so first, assume the event that we draw the paper is A and the sample space is S. So we have question A, the second smallest number drawn is 5. So if the second smallest number drawn is 5, then we have 4 choices for the smallest number, right? We have 1, 2, 3, 4. So that we write that down, that probability of A is equals to the A divided by S. So for the smallest number we have 4 choices, and then we choose 5 for the second smallest. So we have only 1 choice, and then we have 20 choices for the remaining numbers, right? Because we choose the 1, 2, 3, 4, 5, and we have to make sure the remaining 4 numbers are greater than 5. right? Because 5 is second smallest. We have to make sure the remaining 4 numbers are greater than 5. So we have 20 choose 4. And the whole sample space is just 25 choose 6, right? Because we want to choose 6 slip of paper from a 25 set. That's the question A. And question B, the fourth largest number drawn is 15. Okay, this time we want to find the fourth largest, and we choose 3 numbers smaller than 15. We have 14 choose 3, right? So probability of A equal to A BS, we have 14 choose 3. So why is 14 choose 3? Because the fourth largest number is 15. So for the first 3 number, we have to choose 3 out of 14 numbers, right? From 1 to 14. And then we choose 15 for the fourth largest. So we have, we have only 1 here. And for the remaining 2, we have 10 choices, right? We have 25 minus 15, choose 2, right? And it's 25 choose 6. So it's just 14 choose 3 times 1 times 10 choose 2 divided by 25 choose 6. That's the question B. And we have C. The second smallest number drawn is 5, and the first largest number is 15. Okay. So let me write that down first. We choose a number smaller than 5. That will be the smallest number. And we have 4 choices, right? And we have 1, 2, 3, 4. 1, 2, 3, 4. Then we choose 5. 5 is the second smallest. And the third number should be between 5 to 15, right? And finally, the last one, the last 2 should be greater than 15. So from the 5 to 15, we have between 5, we have 9 choices, and we choose fourth largest number should be 15, so we have 1. And for the last 2, we have 10 choose 2. So that will be 4 times 1 times 9 times 1 times 10 choose 2 over 25 choose 6, right? And notice that here is 9 because the fourth largest is 15, so we cannot choose 15. It's just from 5 to actually it's from 6 to 14. Yeah, that's the question 2. Question 3 is about a conditional probability. It's about the probability of A of set B and the complement of set A, complement of set B, the A unit B, the complement, and A intersect the complement of B. Something like this is a conditional probability. So the question says let S be the sample space for an experiment, and let A, B be the events from S, such that probability of event A is 0.4, and probability of event B is 0.3, and probability A intersect B is 0.2, right? Determining the probability of complement of event A, complement of B, A unit B's complement, and A intersect complement of B and A unit complement of B, right? And so for the first one, we have the probability of complement of A. We know the probability of event A is 0.4. So the probability of complement of A is just 1 minus complement of probability of A. Sorry, the probability of complement of A is equal to the 1 minus the probability of A. Yep, that's it. So we have 1 minus 0.4, we got 0.6. Similarly, for the probability of the complement of even B, we have 1 minus probability of B is just 1 minus 0.3 is just 0.7. Pretty simple. For the probability of A union B, we have by the probability of the conditional probability, we have PA plus PB minus PA intersect B, which equals to 0.4 plus 0.3 minus 0.2. It's just 0.5 by the probability of conditional probability, right? And we have the probability of the complement of A union B. Well, similarly, if you want the complement of something, you just use the 1 minus the probability of that event. So we have 1 minus probability A union B here. We got A minus 0.5 is 0.5, right? We have, because we calculate the probability of A union B is 0.5 in the last step. And the fourth, we have probability of A intersects the complement of B. So probability of A intersect complement of B is just the probability of A minus probability of A intersect B, right? So how can we know that? If you draw a Venn diagram, so here we have A and B, which is A, this is B, and color the complement of B is just this one. And A intersect complement of B is this part. It becomes green, right? Because yellow plus blue is green. And this green part is the probability of A intersect the complement of B. So obviously it's just probability of A in minus this part. This part is A intersect of B. So we have 0.4 minus 0.2 is 0.2. But please be aware that if you are asked to prove something, you cannot just use the Venn diagram. Venn diagram is just illustrate. So you have to prove, if you want to prove two sides is equal, you have to use them like the subside, the probability of subside or something else, but not just the Venn diagram. For the last one, we have probability of A union complement of B. A union complement of B, we have probability of A plus probability of complement of B minus probability of A intersect complement of B. And we have probability of intersect or complement of B is just, here is 0.2. So we have 0.4 plus 0.7 minus 0.2. That will be 0.9. Yep. And it's just by the property of conditional probability. Yeah, that's the question 3. Question 4 is pretty classic, I think. It asks you to find the probability that at least 2 of the missiles, it sounds like missile ramen. I'm sorry about that. At least 2 of the missiles hit the arsenal. And it states that 3 missiles are fired at an enemy arsenal, and the probabilities the individual missiles will hit the arsenal are 0.75, 0.85, and 0.9. So if you are asked something like at least 2 of the missiles hit the target, you can simply subtract the result that exactly 0 hit the target and exactly 1 missile hit the target from the whole probability, I mean from 1. So we have like, but okay, so in this question, there's no difference because we only have 3 outcomes, right? But you may face some question like hundreds of outcomes. So that's better to use the method that from subtract the probability of something from 1. So this time I'll use this method. So we have probability of at least 2 equals 1 minus probability of exactly 0 hit the target, and probability of 1 missile hit the target. So we have, so first we have none of the missiles hit the target. We have probability of 0 equals to 1 minus 0.75 times 1 minus 0.85 times 1 minus 0.0. We have 0.00735. And we have the only single missiles hit the target. We have 3 situations. The first missile hit the target and the remaining don't. And we have second, third hit the target. So we have probability of 1 equals to 0.5 times 1 minus 0.85 times 1 minus 0.9. We have so not in. So we have plus 1 minus 0.5 times 0.85 times 1 minus 0.9 plus 1 minus 0.5 times 1 minus 0.85 times 0.9. We got 0.01125 plus 0.02125 plus 0.03375. So we have 0.06625. Thus, the probability of at least 2 missiles hit the target is just 1 minus 0.00375 minus 0.06625 is just 0.93. That's the outcome. If you want, you can verify by use you just add the probability of 2 missiles hit the arsenal and all the 3 hit the arsenal. That will be the same as the 0.93. Yeah, I have verified that. That's exactly the same. So you can do that. You can do that yourself. Yeah, you can take that as a practice. Then, so the question 5 will about the property of integer. So we end of the probabilities. From the question 5, we will enter the word of integer. And question 5 asks you to determine the quotient Q and the remainder R for each of the following, where A is the dividend and B is the divisor. And in this question, we will use what we have learned in the primary school, the long division. Okay, so for the question A, we have 123 and divided by 17. We have the quotient is 7, and we got 119, and the remainder is 4. As we know, A equals to B times Q plus R. And so we have 123 equals to 17 times 7 plus 4, and the quotient is 7 and the remainder is 4. So Q equals to 7 and R equals to 4. That's question A. Question B. So we have A equals to negative 115 here, and we can use the long division on the negative A. So first we want, because A equals to negative 115, so negative A equals to 115, and we have 115 divided by 12. We got 9 here. We have 108, and 7 is the remainder, and which implies the 115 equals to 12 times 9 plus 17. But our target is negative 115, right? So we have negative 115 equals to negative 12 times 9 plus 17. And we have negative 12 times 9 minus 17. And if we minus and plus 12, that will have no influence on this equation. So we have minus 12 times 9 minus 17 plus, minus 12 minus 17 plus 12. And we can combine this and this. So we have negative 12 times 10 plus 5, right? Here is negative 17 plus 12. Because we want to make our remainder positive integer, because we have a requirement that the remainder must be greater than equal to 0 and less than equal to the divisor. So the dividend. The divisor. Sorry. We have the negative 12 times 10. So we know the 115 equals to negative 10, and the 12 times negative 10 plus 5, and the negative 10 is the quotient and R is the remainder. So Q is negative 10 and R equal to 5. And for the third, we have C equals, question C, we have A equal to 0 and B equals to 42. And so we know that 0 is divided by every integer. So 0 equals to 42 times the quotient Q and plus remainder. And 0 equals to, so if we want to this equation valid, we have to, so what do we have for the quotient and remainder? We have 0, right? So 0 equals to 42 times 0 plus 0, right? So we have Q equals to 0 and R equals to 0. And we verify that. We know the remainder must be greater than equal to 0 and less than equal to divisor. So, and we know R is 0 and is equal to 0 and less than 42. That makes sense, right? That's the question C. And question D, we have A equals to 434 and B equals 31. 434, B is 31. So just a long division. Then we have 1 here, 31, and 12, 124, and just 4, 124. Yep. We have the quotient is 14 and the remainder is 0. So 434 equal to 31 times 14 plus 0. And 14 is the quotient and 0 is the remainder. So Q equals to 14 and R equal to 0. That's the question 5. We just use the long division for this question. And the question 6 is about represent the base 10 numbers in base 2 and base 16. In the lecture slides, we know the base 2 expansion is called the binary expansion of a number, right? And we have like the n equals to ak times to the power of k plus ak minus 1 to the power of k minus 1 plus a1 times to the power of 1. So it's just a1 times 2, and we have a0 times to the power of 0. It's just 1, right? For this question, we also use the long division. So we have 137 and 2 divided by 2. So we have 6, 12, 17, 8, 16, 1. And sorry, this is the a0. And 6, 8, we use the quotation 2 and we use the quotation 6, 8 and divided by 2, we have 3, 6, 8, 4, 8, 0. That's the a1. And we have 34, 2, 1, 1, 4, 7. So a2 here, 17, 2, 8, 16, 1. So that's be the a3. And 8, 2, 4, 8, 0, a4. We got 4, 2, 2, 4, 0, e5, 2, 2, 1, 2, 0. That's the a6. And we have 1, 2, 0, 0, 1. That's the a7. So we have 137 equals to 2 times 86 plus 1. 86 equals 2 times 34 plus 0. And 34 equals 2 times 17 plus 0. And 17 equals 2 times 8 plus 1. And 8 equals to 2 times 4 plus 0. And 4 equals 2 times 2 plus 0. And 2 equals 2 times 1 plus 0. And 1 equals to 2 times 0 plus 1. And so the 174 base 10 is just being battery is, so here is the a7, 6, 5, 4, 3, 2, 1, 0. So we go backward. We have 1, 0, 0, 0, 1, 0, 0, 1. Oh, sorry. I think I have to use this notation, like 1, 0, 0, 0, 1, 0, 0, 1, base 2. That's the A. That is 137 in base 2. And we also need in base 16. So hexadecimal is just base 16. We have 137 divided by 16. We have 8 here. It's 128, and we got 9. And this is the A0. And we have 8 divided by 16. The quotation is the 0, and we have 0 here. We got 8. It is remainder is a1. So we have 137 base 10 is just 0x 18. Sorry, I'm sorry about this. I always use, so hexadecimal, 0x means hexadecimal and 0b means battery. I'm sorry about that. That's just 86 base 16, right? That's the 137 base 2 and base 16. And we need one more. The second one should be 6243. Be 6243. Maybe you want a more simpler way to write it down. So we can use a more efficient way, like this. 62, 43. So we have 2. Assuming it's just the long division, but we can use this form. Like divided by 2, we have 31, 21. And the remainder is 1. 2 plus 1 is 15, 60. The remainder is 1. And divided by 2 is 780. The remainder is 0. And 2, we have 390. The remainder is 0. And 2, we have 195. And 97, remainder is 1. Divided by 2, we got 48, remainder is 1. 24, 0, 12, 0, 12, 2, 6, 0, 2, 3, 0, 2, 1, 1. And 1, 2, 0, 1. Right. This way is more clearly, and I think it's more efficient. And we go backward. We got the 6243 base 10 is just 1, 1, 0, 0, 0, 0. 1, 1, 0, 0, 0, 1, 1. Being base 2. Similarly, so the base 16 we have 6243 is divided by 16, we have 390. By 16 we have, and here is the remainder is 3. And divided by 16 we have 24, and the remainder is 6. 1, the remainder is 8. 16, the 0, and remainder 1. And 6243 base 10 is just 1863 base 16. Right, we go backward. That's the 6243. And the third is 1, 2, 3, 4, 5. So for 1, 2, 3, 4, 5, I will leave it for your practice. And after you write it by yourself, you can verify your answer. Here is just 1, 1, 0, 0, 0, 0, 0, 0. It's triple, triple. And triple 1, double 0, and 1, base 2. So it's triple 1, triple 0, triple 0, triple 1, double 0, 1, base 2. And there's also 30, 39, base 16. You can try it by yourself and verify your answer here, because the way of compute this for the computation is pretty easy. Okay. Question 7. It asks you to convert each of the following binary numbers to base 10. So in question A, we have 1, 1, 0, 0, 1, 1, 1, 0, right? So the last digit is just to the power of 0. And the second last is power of 1, 2, 3, 4, 5, 6, 7. It's base 2. So simply we have 1 times 2 to the power of 7 plus 1 times 2 to the power of 6, 0 times 2 to the power of 5, power of 4, 3, 2, 1, and 0. And 2 to the power of 7 is 128 plus 64 plus 0 plus 0 plus 8 plus 4 plus 2 plus 0 equals to 206 base 10. It's pretty simple. We just go backward from like what we convert the base 10 number to a base 2. For the question B, we have 0, 0, 0, 0, 1, 1, 0, 0, 0, 1. And we you can just ignore the leading zeros, right? So because the 0 0 1 1 0 0 0 1 is equals to the base 10. Oh, sorry, base 2 is just equals to 1 1 0 0 0 1 base 2, because that's the leading zero. So we have to the power of 0 here, to the power of 1 2 3 4 5, right? So we have 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 0 times 2 to the power of 3, 2, 1, and 0. Yeah, we got it. And to the power of 5 is equal to 32 plus 16 plus 0 plus 0 plus 1. And it's 49. That's 49. Yeah, because you can skip the leading zeros. That will simply your computation. So today I talk about the basic probabilities, including the conditional probability, and we introduce the practice for the basic concept of the integer. And next week, I think you will learn the modular operation. That will be more about the integer. Yeah, I think that's all for this tutorial. Please take the practice by yourself first, then watch this video. If you still have questions, just go to the question and answer section and we will help you about that. Thank you. Thanks for listening.